Running heavy machine learning models or high-resolution 3D renders pushes your graphics card to its physical limits. Temperature spike, memory fills up, and the hardware draws massive amounts of power to keep up with the math. To see exactly where those bottlenecks happen, you need a way to read the hardware's internal sensors. For that, we use a built-in utility called NVIDIA-SMI, which stands for System Management Interface. You only need 3 things to start pulling this telemetry: an NVIDIA GPU, your installed drivers, and a command line interface. Because it is a core utility, it installs automatically with your drivers. There are no third-party downloads required, whether you are on Windows, Linux, or the Windows subsystem for Linux. Guessing your hardware limits usually ends in a frozen screen or an out-of-memory error. Reading your telemetry directly from the command line gives you the exact data needed to optimize your workloads and keep your system stable. Open your terminal, type NVIDIA-SMI entirely in lowercase, and hit Enter. This animated diagram breaks down the ASCII table that appears. The box at the very top contains your environment's metadata, displaying your exact driver version and your maximum supported CUDA version. Moving down into the main hardware row for your specific GPU, you will find the current temperature measured in Celsius. The next column over displays the electrical draw. It shows exactly how many watts the card is currently pulling, mapped against its hard physical wattage limit. Shifting right once more brings us to memory utilization. This confirms exactly how many megabytes of VRAM are occupied compared to the total available on the card. This default table gives you absolute precision across all your metrics, but it is a static snapshot. It shows what happened the exact millisecond you pressed Enter. When you launch a heavy compute task, memory and power demands can spike and crash your system in seconds. A static snapshot will miss that completely. This faux terminal layout displays the solution. By typing NVIDIA-SMI Dmon, short for dynamic monitor, the terminal outputs a clean, continuously scrolling feed of your metrics. Instead of a complex grid, you get a streamlined view focused on the active constraints. Watch the PWR column for power, the temp column for heat, and the mem column for memory. The exact moment you execute a Python training script or start a heavy render, you see those 3 columns surge in real time as the GPU takes on the load. This feed will run endlessly. To safely stop it and return to your standard prompt, simply press Ctrl+C. Watching this dynamic feed allows you to catch the exact second a memory leak occurs or a power limit is hit, capturing the transient bottlenecks that a single snapshot leaves hidden. Both the static grid and the dynamic feed are built for human eyes. If you want to feed your hardware telemetry into an external logging script, all that extra visual formatting gets in the way. This diagram shows how to isolate exact variables. We start with the base NVIDIA-SMI command, add the -- query GPU flag, and specify exactly what data we want to extract. To pull your exact VRAM metrics, you add memory.used and memory.total directly to the query string, separated by a comma. To monitor heat instead, you simply swap the parameter to temperature.gpu. And to log your electrical usage, you change the query target to power.draw. Finally, you append the -- format CSV flag to the very end of your command string. This strips away all the visual borders and outputs a clean, comma-separated value. Your metrics are now machine-readable, ready to be digested by automated monitoring dashboards and custom scripts. You now have a complete 3-tier telemetry strategy. You can use the base command to check your environment, Dmon to watch live workloads, and targeted queries to automate your logging. Whenever you initiate a major compute task, open a second terminal window and leave Dmon running on the side. Open up your command line right now and try typing NVIDIA-SMI. Verify your drivers, test the dynamic monitor, and confirm your environment is ready. By reading the telemetry straight from the source, you stop guessing why a script failed, and you start actively controlling the exact physical limits of your hardware.